2 episodes ago, we watched a system adapt. Last episode, we opened the training loop and named the pieces, parameters, loss. Today we ask the question that follows naturally from both. Once a model has actually learned something, where does that knowledge go? By the end, you'll be able to explain exactly what storage means inside a trained model and why the most common mental picture of it is wrong. This matters because almost everyone, the first time they think about it, imagines a model as a lookup system. Type a question, it searches some internal library, and returns the matching sentence. That picture is intuitive, and it is not how any trained model actually works. So let's test that picture directly, the same way we tested the calculator and the thermostat. Here's the guess most people make. Somewhere inside the model, there's a database. Your input goes in, it searches that database, and the matching sentence comes back out. Here's what's actually there instead. Not sentences, not rows. Thousands, sometimes billions, of small numbers. The exact same parameters from last episode, now just called by their finished name, weights. Watch what actually happens when a single input goes in. It doesn't travel down one path to one matching answer. It flows through many weighted connections simultaneously. This is a conceptual visualization, simplified, but the core idea is accurate. No single connection is the answer. Quick prediction. If we could delete exactly one of these weights, what happens? Does one specific fact disappear, or does something else happen? Let's actually do it. Take our tiny house price model from last episode, one parameter, currently sitting at 10. Zero it out completely. The model doesn't forget houses. It doesn't forget price. It just predicts 0 for every single input, uniformly. There was never a slot labeled the concept of price to begin with. There was only ever this one number, participating in every prediction at once. Now scale that idea up. A real model doesn't have one parameter. It has millions or billions. Delete one of those, and the effect is even smaller. A barely measurable nudge to some predictions, spread across an enormous number of weights working together. This is the actual, honest picture of storage inside a trained model. Not a card catalog. A wall of small numbers, each one meaningless in isolation, and only meaningful in combination with all the others. Let's name this properly. Weights are parameters after training is finished, the exact same numbers, just referred to by their settled name once they've stopped moving. A representation is the pattern encoded across many weights acting together. Not one number, not one neuron, the combination. This property has a name too, distributed representation. Knowledge isn't localized to one address. It's spread across the network, the same way a photograph isn't stored in one pixel. Here's a trickier case, on purpose. If knowledge really is spread out everywhere, does that mean every weight matters equally, and none of them are ever more important than others? No, and this is the honest nuance. Some weights do end up mattering more than others for certain inputs. Distributed doesn't mean perfectly uniform. It means there is no single dedicated slot for any one fact, not that every number contributes identically. You already interact with this distinction constantly. Your phone's autocomplete has no lookup table of sentences behind it, just weights. A spreadsheet, or a phone book, is the opposite. Every fact sits in its own dedicated, literal row. That's the entire difference between a database and a trained model. This is also why you can't simply edit one fact inside a large language model the way you'd edit one row in a spreadsheet. The knowledge isn't addressed that way. Changing behavior reliably usually means further training, not a database update. So, to recap, using the same shape as always. Problem: where does a trained model's knowledge actually live? Mechanism: distributed across many weights acting together, not stored in any single dedicated slot. Result: deleting one weight from our tiny model didn't erase a fact, it just shifted every prediction slightly. Limitation: distributed doesn't mean perfectly uniform. Some weights matter more for some inputs than others, and you generally can't hand-edit one fact the way you'd edit a database row. Which leaves the next real question. If knowledge is just numbers, weights, with no inherent meaning on their own, how can numbers ever represent something like meaning at all? That's exactly where episode 4 goes. Quick thread check. Since these 3 episodes lock together, we defined intelligence as adaptation from feedback. We opened that adaptation up and found training, loss, and parameters underneath it. And today, we found out where those parameters actually end up living once training stops. Each answer created the next question. That's not an accident. That's the format. weights, representations, distributed knowledge. You now understand what storage actually means inside a model. Follow AllAboutAIVerse, and let's keep going, one honest idea at a time.